Hello and welcome to this week's What Were They Thinking? Among the variety of news items we have for you this week, West Nile is in the UK and no, we haven't got our geography wrong. Scientists find a clue as to why men are taller than women. How boredom could actually be beneficial for your brain, although perhaps not so much for your productivity. Cannabis might be used as an antifungal treatment in very limited cases. Trees can, to an extent, predict when a volcano will erupt. Using biology to create a multimodal or essentially ChatGPT clone. CERN has been able to make gold using the Large Hadron Collider, although very temporarily, making all of the alchemists jealous. And Harvard has proven an item we reported on last week to not just be true, but far more scandalous than what you first thought. The timestamps for these and other news items can be found in the description box below. Let's start with West Nile virus. The West Nile virus is something that has basically been prevalent in Africa for a long time. We're looking somewhere roughly 1935 to 1940, and it's in the same general virus family as dengue and yellow fever. What makes it a worry with its presence in the UK is that it wasn't found in a human host. That by itself would be a bad sign, but that's not a big problem. Instead, it was found in mosquitoes. This means that, first of all, we have mosquitoes carrying West Nile, which means new victims who have been infected, but it also means that somebody got into the UK with it, stayed long enough, and was fed on frequently enough that they then allowed for it to be, well, in the wild. This means there's now a wild reservoir or reserve of West Nile virus in the UK. It's going to be very hard, if not nigh impossible, to get rid of it as a result. The next issue is, well, although it may not necessarily kill everybody, it's certainly going to cause some problems. About 80% of cases don't have a lot of symptoms. Some of the more extreme cases generally have more notable features or symptoms, fever, fatigue, headaches, body aches, and so on. But there is a rough risk of 1 in every 150 of the people dying. Although we should say death is generally going to follow a lack of treatment and certain other considerations, such as encephalitis or inflammation of your brain. So yeah, this is not great. There are other theoretical answers as to how this may have reached the UK, for example migratory birds, and similar, but it's more likely to be humans in many cases. So this is not great, especially since there's really no actual treatment for it. There's nothing available to make it go away once you have it, and there's not a great prophylaxis vaccine either. Shifting to more shitty news, we literally have pooping, and how for some people it can kill. This might sound like a really dumb joke, or say something from The Simpsons.
Oh, here it comes!
But no, apparently, if you are pooping, and for very rare individuals, parts of the heart can basically fail, which is rather funny. What makes going to the toilet one of the more dangerous exercises for some individuals is that you are forcibly exhaling air against a closed airway because you're straining, probably because you don't have enough fiber in your diet, and this then puts pressure on your chest, and that affects blood flow back to the heart. For most people, this is a relatively minor issue. It's going to lead to some people experiencing defecation syncope, basically lightheadedness, sometimes an irregular heartbeat, and in those very rare cases, death. Why it happens is the vagus nerve. The vagus nerve is one of the biggest nerves in your body, or at least longest, and the process of exhaling so forcibly causes it to be slightly squished, and that then affects heart rate, that affects blood pressure, and then that affects consciousness. It's a series of cascading events that ultimately end either with a relatively little effect or a very significant effect. So, although this is rare, it can happen. So, it's another thing to worry about when you're living your day-to-day life. How many ways can you die? Shifting to day-to-day news and things that most people would recognize, men are generally taller than women. You look at the average bell curve of distribution for both males and females, and the average for males is higher. Sure, there is overlap, but there is a clear distinction with two distinct peaks, one for each sex, and they are separated. The reason for this is arguably purely genetics, but according to Pennsylvania-based research, and it does involve a few thousand adults, but yeah, you should probably take that with a bit of consideration, it's the chromosomal combinations and how unusual they are for each sex that leads to males being taller. There is a common chromosomal issues, or at least genes, found between the X and Y chromosomes. These are called SHOX, short stature homebox, and this gene is, well, exactly what it says. It affects stature or height. Because males only have one X chromosome, this leads to it being deactivated. As a result, inactivation of it means that you just don't get that shortening effect, whereas females have two X chromosomes, and so even if you turn off one, the other is still active. It's a surprisingly straightforward explanation. The research would indicate that the inactivation of the X chromosome in females leads to an additional roughly 3 centimeters or about 1 inch of height. The difference itself isn't just down to that though. This will account for about a quarter of the height difference between males and females, so it's not a complete explanation, but it is a significant contributing factor, given we are talking about, well, roughly a quarter of all possibilities. And the things that you may want to consider, now that we've told you all these horrifying news, and particularly how you might die in the toilet, are mindfulness and meditation, and that this might actually be not so good for you. The research is based on a very small study, and it's a few years old now. It's from 2022, and it involves about 950 people. What they found was that about 10% of the participants had adverse effects from doing so, and this affected their everyday life for at least a month. Which, yeah, that's not a great thing. The whole point of meditating and being mindful is not to have negative effects, or possibly to deal with your repressed anxiety and angry thoughts.
Well, game night was a success.
Peter, you do know that all your questions were incredibly easy.
Yeah, easy for me. Good night, morons.
You ever stop and think, wow, I'm married to that guy?
Nah, I just repress it.
Is that healthy?
What's the worst that could happen?
I'm a tumor, I'm a tumor. I'm a tumor, I'm a tumor, I'm a tumor. I'm a tumor, I'm a tumor, I'm a tumor. Oh, I'm a tumor.
This is followed up by a review of about 40 years of research, which we would argue is a rather long time frame given substantial changes in the data, but sure. What happens is that, other than the fact that individuals may experience, well, let's say negative effects, it comes down to the nature of it being relatively unbalanced in all the available instruction and information. What happens is that just because you're aware of something and you think about it doesn't mean you're going to be better off. In fact, for a lot of people, thinking more about what you're angry about, anxious about, or sad about may just make it worse. It's kind of obvious. But bearing in mind that this is generally done under some degree of instruction, whether it's pre-recorded or some sort of yogi or similar leadership, or in some cases just a plain old cult. So yeah, mindfulness and meditation may not solve all your issues. In something else that's inside your mind, and you may wish to consider, is being bored rather than mindfulness or meditation. Being bored is perhaps one of the worst feelings you can possibly have, simply because people are sitting there going, well, I want to do something, I want to be stimulated, I want to be happy, because endorphins make us feel good. But then again, constantly getting that endorphin rush may not help you in every respect. This is where we look at what happens to the brain when you are bored. That is, you've lost interest or you've become disconnected from whatever it is. The nature of the activity of the neurons in your brain will decrease, which reflects a diminished interest in whatever you're trying to do or being involved in. For example, a boring work meeting or attending some sort of religious service. In your brain, having that slow down and shut down of what happens can then affect the ability of your brain to basically relax and recover from what's happening. This is more pronounced in, say, the amygdala, where your emotions and similar are all housed. By having the processes there, relaxed and settled down, you're not stimulating it. Your brain has been given a chance to go, okay, reset time. With the extensive, let's say, diagnosis of ADHD, and particularly for school kids, this is possibly one way to look at using the information, possibly, other than drugs, but, well, drugs are good, and of course, school kids are always stimulated because they have to avoid the live fire exercise course, that is, well, school classrooms. Next, we want to talk about a very large-scale study focusing mostly on children, or at least you'll see its ramifications for children. It's called SPARK, and it's a very large study looking at autism. SPARK stands for Simon's Foundation Powering Autism Research, and it's a not necessarily a long-running study, but a very large study at this point. The study first started in 2016, and there are roughly 157,000 people with autism and about 222,000 of their family members involved. This is important for a number of reasons. First of all, we have the sheer size of the study, and this is, of course, not necessarily retroactive analyses of data, but more at this stage observational understanding of the data. What they want to look into is the medical and behavioral information that's available from it. For example, they're asking people to mail in saliva for genetic analysis, which could help substantially in specifically analyzing and identifying which genetic mutations are responsible for autism, which would hopefully and finally put the ridiculous notion that vaccines cause autism to rest, but we're rather pessimistic about that outcome. Further, there is, let's say, requests to provide, well, other data, for example, on behaviors and similar. Now, being relatively early in the study, looking like this will be for a very long time, it's likely that this will be far more useful than, let's say, other studies, which have had only a single snapshot of when and what people were doing and how their genes have changed over time. In terms of things changing over time, we have a novel use for cannabis, or at least a compound within cannabis. It might prove to be a rather good antifungal, might being the key word here. The researchers believe, and it's kind of important to be very skeptical about this, that things like Cryptococcus neoformans and Cryptococcus meningitis could be particularly vulnerable to cannabidiol and cannabivarin. These are both compounds that are found in cannabis sativa. Theoretically, this would be useful because there are certain fungus issues that are becoming pathogenic and resistant to antifungals that are available now. It's a relatively understated threat, at least by comparison to, say, antibiotic resistance. This is a also rather useful approach because, theoretically, it could be useful, and it's very important to say this with a great deal of skepticism, that they could prove to be novel antifungals. The could being the operative word there, as it's hard to say exactly how well that would happen. This, of course, does also require that, well, the antifungal be producible and usable, given that it is derived entirely from, well, cannabis, which is a bit of a problem. In other plant news, but plant news that is, well, far more alarming, and also somewhat obvious. A reduction in oxygen would lead to loss of life on Earth. Which, yes, that is typically what happens. Without oxygen, life suffocates, and suffocation, in most contexts, is bad. And outside of the particular fetish circles where suffocation is a thing, well, yeah, it's not enjoyed. The reason for this claim is not actually based on a concern about the current environment necessarily, but rather we're talking about archaeological records, the Great Oxidation Event from about 2.5 billion years ago. What happened as a result? Well, obviously there was a huge change in atmospheric CO2 levels, with them going up and oxygen going down. Mostly because, well, oxygen likes to react. O2 is not a very stable species. So anywhere and anything that can make use of it will grab it, break it into individual oxygen molecules, and bind. This is where the Great Oxygen Event is, well, Great Oxidation Event, let's say, is useful to understand what happens. Other than the possibility that we could have this massive shift in increasing CO2 levels, the opposite could also be true. That is, if you have a sudden reduction in plants, and for that matter algae and similar, you have a drastic reduction in photosynthesis. No photosynthesis means no oxygen. It's a fairly basic understanding that most people have of what plants do. Plants make oxygen, they do so via photosynthesis. So if, for example, we start culling massive areas of rainforests, polluting the oceans and similar, you could make a case that there will be a substantial decrease in oxygen production. And not such a substantial reduction that we'll all die from suffocation, but it could have an effect, just not yet clear on how much of an effect. In other plant-related news, we have trees being able to predict volcanic eruptions, which kinda makes sense. First of all, volcanic eruptions are dangerous, which, again, obvious, but predicting volcanic eruptions isn't so easy. We can kinda know when they'll happen in a very vague sense, such as, we might expect this volcano to erupt in the next 6 months. Not a very helpful approach. If we can narrow it down to, okay, over the next week, much more helpful. And what happens is that as the magma from the volcano gets pushed increasingly close to the surface, trees can sense this change in heat along with other things, and then they start changing the genes that they express. The research is based on Italian studies, so we need to be mindful of this, since at least trees around the area, that is Mount Etna, will probably have a good idea that, being exposed to excessive heat and molten rock is bad for them. So, again, some, skepticism should be taken. What the trees do is kind of brilliant, though. What happens is that the trees alter their gene production, or gene expression, let's say, directly in prediction to volcanic eruptions, and part of that is not just the heat, but from the seismic waves and the changing ground height. When you combine this with the alteration in carbon dioxide emissions, trees go, aha, that's what's about to happen. This is not great. Of course, trees, at least in our world, can't run away from it, so until we find the ends, this is not going to be much use for the trees. In more useful research, although still plant-based, it's a clinical summary of the benefits, let's call them, of golden rice, and specifically looking at the fact that, groups like Greenpeace keep trying to kill children because they're assholes and hate everybody and everything that isn't an animal. They're not quite on PETA levels, but they're getting there. In short, low and middle income countries, so basically developing and very broken countries, need vitamin A fortified rice, or golden rice, and there is a clear benefit to this. And of course, you can actually draw comparisons and understand that golden rice is not the only example, but it is one of many. Shifting now to more biological news, although it's the junction between biology and technology. It's using biology to create what for all intents and purposes can be considered a sort of machine.
My God, it's beautiful. Half computer, half living organic matter.
That looks like barf. I miss Lucy.
To be clear about it, it's certainly not a perfect machine because, its ability to do anything is somewhat handicapped, and of course, understanding what's being done and then interpreting or at least seeing what's going on is also very difficult. What the researchers are doing is using DNA, and DNA itself, because of how it changes, it's being turned on or turned off, and in other cases, simply by using the various nucleotides, you can create an almost perfect analog for the binary system. Where this gets kind of creepy in a way is that researchers are looking at using this biological deep learning machine or large language model similar to ChatGPT, Gemini, and so on, to then figure out not only what other organisms are made from, but how to then modify them. So it's essentially a biological system figuring out how to modify another biological system that would then improve the original system. It's like AI making better AI, except this is biological and, as a result, somewhat terrifying. Next is not so terrifying, but it could be the use of lasers to do things from about 1.5 kilometers or a mile away. Well, thankfully it's not yet terrifying things, although the FBI and CIA might actually find use for it.
I want to get away from that farm, more than anything. But it's not worth living in a world where China controls my country's arts.
It's a laser that can read things from about that distance, give or take a short ways. What they've been able to do is get a laser and allow it to analyze writing, normal-ish writing, from 1.5 kilometers or about 1 mile, and not only understand what is said, but then output it in a way that is useful. The Chinese research, which kind of unsurprising given China's relatively intrusive and invasive monitoring of anything and everything, could be useful in ways that are not so obvious. Well, not so obvious in terms of not being so invasive and intrusive monitoring of people and dissident thoughts. The researchers could be using this, for example, in analyzing topological features on the moon without having to go there, although that would require a laser, and lasers don't like going through the atmosphere. That's also ways to say, for example, analyze incredibly tiny documents and writing, spy documents for all intents and purposes. The use at this moment, though, is fairly limited because, well, although yes, you can read them at a ridiculous distance, it only goes down to the size of 3 millimeters, which is roughly 1/8 of an inch, and up to 42 millimeters, which is just shy of 2 inches. In news that has received a fair amount of attention, but not properly so because it doesn't really deserve it, CERN and its project called Alice has created gold from lead. Now, transmutation of lead into gold has been the, ironically, golden grail of alchemists for an incredibly long time. Of course, they've never succeeded, or at least never been able to prove themselves successful. But of course, they didn't have themselves a giant, massive, high-speed collection device that basically goes near the speed of light. So naturally, they couldn't do so. By taking lead particles and smashing them out with protons, they could take lead and turn it into gold nuclei, which, again, sounds cool. After all, if CERN can start making its own gold, it could theoretically pay for itself. Not likely given how little they make, but theoretically, they could start making some sort of money. The challenge with it is this: the gold they make was only in existence for fractions of a moment, and we mean really, really tiny time here. The, first of all, process involves taking 82 protons that are in the nucleus of their lead and charging it up to the speed near the speed of light, roughly 99.999993% the speed of light, so as close as you're going to get in all practical terms. They then get squashed into a pancake in their direction of motion. From this, they then allow the dissociation of the photons and the nucleus. This allows it to start oscillating, and that created the gold. You had to go from having 82 protons to having 79 protons for that to occur, and therefore 3 protons are removed from the lead nucleus in this beam. Again, sounds all well and good. And of course, when you look at what they actually did, they made roughly 86 billion gold nuclei during the second run. However, in terms of how much gold that actually makes, it's about 29 picograms. Picograms are, well, in this case it's a 2.9 by 10 to the negative 11th power. If you were to try and write this out, it would basically be 0.0 repeated 11 times to 9 grams. So, nothing. And remembering that it doesn't actually last all that long, which is the major caveat to all of this. Sounds cool, but they do break down if they're not stable. And theoretically, in this case, because they're able to extract the protons, they might be able to maintain that gold production, but it's not really all that valuable. In news that throws back to last week, we have the Juno controversy. That is a researcher who appears to have published extensively, and fraudulently so, committing effectively the scientific equivalent of heresy and blasphemy. Now, it's important to note that it's taken a stupidly long time for this individual to be punished in any way, shape, or form. First of all, they were working at Harvard, so that raises concerns for us right away. But their dishonesty didn't really have any effect on them. After all, this was reported to Harvard 3, 4, 5, 6, and even 7 years ago in some cases, and it can go even further back again. And it took them that long to finally go, okay, you've demonstrated that they're fudging their data, they're actually making up results, and they're refusing to do anything about it. Well, yes, finally, results. The prominent Harvard researcher has been stripped of their tenure and fired. You would think that this wouldn't take so long when you literally make up data. There is literally no other way for this research to have been done the way it was claimed. A student, quite literally, took the published available data, that is the supposed original data that was undermining all of this particular research, did the same methods themselves and went, they're not the same. That should not happen. There is no way, shape or form in which, with the same dataset and the same method, you should get a different result. So they tried to take it up the chain, as we reported last week, and failed. So they took it externally, and another group did exactly the same thing, repeatedly, multiple times and in multiple ways, and tried to find any alternative other than fraud. And even with their strongman approach of trying to get the best possible match, still could not make it happen. And so now, finally, years later, we have results, which does speak to how kind of broken academia can be at times. The final news item we have for you takes you to the outer world, and specifically to a star that's orbiting inside another star. This is not normal. In fact, binary star systems, although not common, are not rare. But a star orbiting within another star? Yeah, that's where things can get strange. And it's an exception within an unusual phenomena. In fact, it's entirely possible that this is exactly the same explanation as we were proposing for an event last week. The two stars are basically circling each other, and very closely too. One of them is a rare pulsar. This means that as the bigger of the two stars, in some respects, releases signals, the partner star, which circles around it, blocks our ability to detect or see that signal, and this occurs roughly every few hours. As a result, you can more or less identify the fact that it's a pulsar because it literally pulses. The discovery was a product of China's giant telescope. It's a radio telescope. It's very similar to, say, Arecibo, if you're more familiar with that. It's a huge mountainous cavern that's had a huge dish put into it, and then over that hangs the various receivers. Although the discovery itself isn't all that exciting, it is interesting and might, theoretically, contribute to our understanding of what goes on in space, and particularly the life cycle of stars. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. And please do post any comments, questions, or suggestions you have below.